All right, welcome to section 2.4 in your student journal, solving multi-step inequalities. This is pretty much a rehash of chapter 1 plus, with the addition of the concepts in the past 3 sections where, essentially if you do it on the left side, you got to do it on the right side, or if you do it on one side, you got to do it to the other side. That applies to addition, subtraction, multiplication, division. This is page 43 of your student journal, by the way. The only notable difference being that when you multiply or divide by a negative, you have to swap the inequality symbol. So with that being said, I'm going to go through and just solve these problems by hand to show you. I'm not going to draw the number lines because we've been doing that for a couple sections already. I just want to focus on how to solve these. So again, you treat your inequality symbol like the equal sign. So to create your left and right side, so you add 2, and you get 3x is less than 12. You divide both sides by 3, and you get x is less than 4, right? So you got your 4, 5, 3, x is less than 4. There's no equal sign, empty circle, less than, 3 is less than, so we will go to the left. Subtract 8 here. Oh, let me make that border wall again. Minus 8. Sorry, that's so ugly. Minus 8. We get 4a is greater than or equal to negative 8. We're going to divide both sides by 4. And we're going to get a is greater than or equal to negative 2. Notice that because I'm dividing by a positive number, even though this 8 is negative, it's not the number I'm dividing by. So the symbol does not change. A is equal to or greater than negative 2. Start off at negative 2. The circle is going to be filled because it has an equal sign. Greater than means to the right, so our arrow is going to be facing that away to the right. Moving on to number 3. First thing we're going to do here is going to get rid of that 2. It's a positive 2. How am I going to get rid of it? Minus. There's your barrier again. Okay, minus 2, minus 2. B over negative 3. How do I divide by, or sorry, this is b divided by negative 3 is less than or equal to 1. And what is the inverse operation of a fraction or dividing by? Multiplication. So multiply. So I get, when I multiply or divide by negative, what happens to the symbol? Let's change that first. B is equal to or greater than negative 3. Okay. Over here, we'll add by 6. I keep forgetting. Sorry about that. Here. Well, I would do it for that, but we got to scroll down first. So add 6, negative c over 2. Greater than negative 8 plus 6 is negative 2. Actually, I'm going to pause here for a second. Some people always ask, or not some people, but students, someone in the class always asks, what is negative? Because it's right in the middle, right? So it's kind of like ambiguous. And the truth is, it's ambiguous because it can be the numerator or the denominator that is negative. And some students ask, can both of them be negative? And the answer is no, they both cannot be negative. If it was two negatives, then it would just be a negative divided by a negative, which is positive. So when you see a negative in front of a fraction, it applies to the numerator or the denominator. It is entirely up to you, and it makes no difference. So to cancel out this divided by 2, I will multiply by negative 2. And when I multiply by a negative, let's go ahead and just help ourselves and flip that inequality symbol. So you have c is less than 4. That's it. Okay, moving forward. Number 5. We got negative. We're going to distribute this negative 4 by multiplying it. Negative 4 times d is negative 4d. You already know you're going to end up dividing by that negative 4, or you should, at least, if you're cooking up on the pattern quickly. You will end up dividing by that negative 4, and when you divide by negative, you will swap the sign. But let me make that barrier. 4, so we got 12, less than or equal to negative 4d. Oops. divide both sides by -4. What happens when you divide? You gotta swap the symbol. 12 divided by -3. 12 divided by -4 is -3. And the d is on the right side, which is okay. But on standardized tests, you will see that the format for that is put the variable on the left side. When you switch it, -3 is greater than d is the same thing as saying greater than or equal to. It's the same thing as saying d is less than or equal to -3. Right? So when you swap from left to right, then you also swap the inequality symbol. Okay? I'll leave that. I'll leave those problems up to you guys to graph. If you're not sure how to graph, just go to the last section or 2 sections, and it'll be there for you. Solve the inequality. So 5 minus 2n. So this one I will just bring to the right. Just because I feel like it. You could do whatever you want. If you wanted to add 4n, you could add 4n. But I will add 2n. So I'll add 2n. 5 greater than 8. -4 plus 2 is -2. I will subtract this. I'll subtract it from the left side as well. 5 minus 8 is -3. Is greater than -2n. How to get rid of that -2? -2 times n. Gotta divide. But when I divide, let's just go ahead and get ahead of ourselves. Oops. I didn't swap anything. I swapped the sign. So negative divided by negative is a positive. 3 over 2 is less than n. Or n is greater than 3/2 or 1.5. It doesn't matter which side you want to bring it on because they are the same. 0, 0 at -18 is less than +1. Is a negative number less than a positive number? I'll pause and let you think about it. The answer is yes. -18 is always less than -1. Infinitely many solutions. Earlier I brought the 2n, brought the n over to the right. This time I'll bring the p over to the left. Just to switch it up. Show you guys some variety of technique. So 3p plus 7p, or sorry, 3p plus 4p is 7p, plus 4 is greater than or equal to 25. How do you get rid of that? Or what am I going to get rid of first? 7 or the 4? Pattern is to, or going from inverse up, or inverse order of operations. Oof. Addition, subtraction comes last, so I'm just going to attack that first. 7p equal to or greater than 21. Divide by 7. Divide both sides by 7. I'm not going to write it out just to save some time. P is equal to or greater than 3. Well, I guess you could just speed up the video if you want to save time. Okay. This one is not far off. You just got to combine like terms. 7j minus 4j is 3j. 3j plus 6 is less than -2 plus 3j. I want to subtract 3j from both sides. So I subtract there. That's the right side. And I'll subtract there from the left side. So that 6 is less than -2. Is that true? Is a positive number less than a negative number? No. So no solutions. Or no solution. Here, it's just an issue of distributing. So I'm actually just going to write it out. So we got, let's see here, we got 12 times 1 is 12, divided by 4 is 3w, plus 12 times 3 is 36. I'll put the symbol in later, 3 times w, distributing it, minus 12, distributing that 3. I'll mark it up for you as well. Less than or equal to, we subtract 3w, we subtract 3w, sorry that w came out kind of funny. 36 is less than or equal to -12. Is that true? Is it positive? No, no, no. It's just exactly like the last problem. So no solution. Okay, now we're on the last 2 problems of this section of your student journal. Find the value for which the solution of the inequality, blah, 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 is all real numbers. That means we want to get to this point by essentially canceling all the variables we can, and whatever resulting inequality we get, if it's also all real numbers, then the inequality, when we read it out loud, should be true. If it was not, then it would be false. So k for r, now we're just going to distribute these. So we have 4 times k times r. We'll just go in alphabetical order. 4kr minus k times negative 5 is negative 5k, negative 12r. And so, like I said, we're looking to make sure all the variables are gotten rid of. And how do we do that? And that the resulting inequality is true. So let's look at this. We got to get rid of the k, which is easy because we are choosing whatever k is. It says find the value of k. You get to pick, or you get to figure it out. And r is just some variable r, but I want to make sure that they are in 2 locations, right here and right here. And I want them to essentially cancel each other out. So I want them, since they're on different sides of the inequality, then I want them to be equal to each other. So you got to ask yourself, if 4kr, I want them to be equal, then what do I have to multiply 4 by to make negative 12? Because the r is there for both sides. So they're both being multiplied by r. I'm not worried about that. 4 times what is negative 12? Well, if you're not sure, we will divide by 4r. We will divide by 4r here. And we will say, boom, boom, negative r's cancel out. 12 divided by 4. K is equal to negative 3. So let's plug this in and make sure it makes sense. Negative 3 times positive 4 is negative 12. And nothing has happened to the r yet. And if I replace this with a negative 3, I also have to replace that k with a negative 3. So 5 times negative 3 is negative 15. Notice the parentheses I'm putting around it, because I know there's a minus sign. Some of you are like, oh, if there's a minus sign, do we got to put a negative? Yes, the answer is yes. Negative greater than or equal to negative 12r minus 9. If we add 12r to both sides, which we will, they will just cancel out. And this minus a negative turns into positive 15. Is 15 greater than negative 9? Yes, it is. Then k is equal to negative 3. That is appropriate. Here, I got 2kx, and I'm actually just going to start off by subtracting. I just want to simplify this a little bit. So I'm going to subtract 2kx. So I got negative 3k. Negative 3,000? Nope, just k. Less than 2x plus 4 plus 1kx. Again, I said we wanted to get rid of the variables. In this case, we get to pick k, but x is just something. And we want, if it's no solution, then whatever inequality we result in has to be not true. It has to be false. Should have just said it. It has to be false. It has to be wrong. So if we look at this, I have a 2x plus kx. You got to think, what value can I use? And because they're on the, I know earlier I said 4kr equals to negative 12r. That's because they are on the opposite sides. But since they're on the same side now, I want them to cancel each other out, which means that if this is positive, I want this to be negative, right? To make it 0. So if I have 2x and I substitute a negative 2 in for k, let's just see how that will work out. So I want them to be opposite of each other. So I want kx to equal negative 2x, opposite as in opposite sign. So divide it by both sides by x, boom, boom, negative 2 equals k. Well, let's check. Negative 3 times negative 2 is negative, or positive 6. And even though k is negative 2, you know, that has nothing to do with multiplying anything, or sorry, multiplying the whole inequality by a negative, so there's not going to be any flipping or swapping of signs here. 2x plus 4 plus, now what do we replace k with? Negative 2, right? So negative 3 times negative 2 is positive 6. Negative 2 times x is negative 2x. So I got 2x plus negative 2x. That will just cancel out. I have 6 is less than 4. 6 less than 4? No, it's true. So, or sorry, it's false. No solution. K is equal to negative 2. All right, guys. So again, if you understood chapter 1, this is very, very related. Pretty much all the principles are the same. The only thing you got to remember is that for inequalities, when you multiply or divide by a negative number, the inequality symbol swaps. Otherwise, it is exactly the same as chapter 1. All the principles is what I'm referring to. All right, I hope you understood it. If you didn't, as usual, ask me or ask your teacher.